Hello, students. Welcome back. We're talking about continuity. So we've talked about limits, and now we're going to use limits to talk about continuity. So what is continuity? What are the three types of discontinuities? And what is the three-part definition of continuity? That's what we're going to talk about today. So I think it helps if we look at graphs of each of these. So first off, we have a continuous function. And a continuous function is a function that we can draw by putting our pencil down and not picking it up. Now, of course, at the end, we can't draw this forever, but we have arrows that imply this function will just continue. So in the purple function, we have no problems here. The limit at every value is the same as the value of the function. However, if we look at the red function, we see that we have an issue at this value of c. If we were drawing this function, we would come to a point where we had to pick up our pencil and draw this point above. This is called a removable discontinuity, or a hole. Let me make that a little smaller, or a hole. And then we continue down here on the bottom left, we have a function that at c, we're fine. We have a continuous function on the left. And then once we get to c, we pick up our pencil and then we bring it down here to about -4 and start drawing again. This is called a jump discontinuity. And you might notice here, in the removable discontinuity, we actually did have a limit at c. As we approach c from the left, it's the same as whatever we approach c from the right as. However, at the jump discontinuity, the limit as we come from the left is about 1, whereas the limit as we come from the right is about -4. So the two-sided limits would be unequal. And then finally, we're looking at the asymptote at c. So coming from the left side, we go towards infinity. Coming from the right, we go towards -infinity. And we call this an infinite discontinuity. And let's take a look at how these limits work out at c for each of these. So for the last one, the limit as x goes to c from the left of f of x is equal to infinity, and the limit as x goes to c from the right of f of x equals -infinity. So because one of these is infinity, or actually because both are infinity or -infinity, we have an infinite discontinuity. The jump, I'll scroll down a little. The jump, the limit as x goes to c on the left is, let's say it's 1. And the limit as x goes to c from the right is about -4. So for a jump discontinuity, the two-sided limits are unequal. One side in this case was 1 and one was -4. But they're not infinity. They're both values. And then if we go up here to our removable discontinuity, we do have a limit here. The limit as x goes to c of f of x. It is, I think I drew it at about 2.5. But this is not equal to the value at c. This is not equal to f of c, which f of c is about, I don't know, what is that? 5? F of c is equal to 5. So this takes us to our three-part definition of continuity. First off, the limit as x goes to c of f of x needs to exist. So the limit as x goes to c of f of x exists. The second part, f of c exists. And I'm not someone who loves memorizing things, but I do like to make things easier. So that's why I'm picking these colors. You'll see that we, yes, have a lot of parts to this, and it's kind of overwhelming to have to memorize all of these. But you'll see that we actually only have 3 things that we repeat 2 times each. So the limit as x goes to c of f of x, we have that in the first part and in the third part. F of c we have in the second part and in the third part. And exists are in the first and second part. So if we have a limit at that value, if we have a value at that x value, if we have a y value at that x value for the function, and they are equal, we have a continuous function at that point. If we were to look at all of these and talk about this point C, for the first one, we see that 1 is good because the limit as x goes to c is equal to about -1. We see that f of c is equal to about -1, so that's good. And those are both equal. So at x equals c, our first function is continuous due to the definition. If we go to our next function, the limit as x goes to c of f of x, that does exist. It's about 2.5, so that's good. When we go to the next part, f of c, that's about 5. So that exists, that's good. But the first part and the second part are unequal. So that's how this function breaks the 3-part definition. And then we'll cover that with the last two. The jump discontinuity, because the limit from the left does not equal the limit from the right, we're actually breaking the first part of the definition already. The second part actually is true. F of c does exist. It's here at 1. We have a filled in circle. So I'll say 2 works. But those values are unequal because we don't have a limit. So 3 is broken. And finally, in infinite discontinuity, our limit, again, does not exist. We actually don't have a value at f of c either. That's an asymptote. And of course, those are unequal because we don't have values for either. All right, so I hope you have a better understanding of what continuity is, how to check for continuity at a point, and a better technique for how to memorize the definition of continuity.